I think the one that I'm stuck on the most is probably use substitution.
Okay. We're going to do one like that, but what kind, is there one specifically that you'd like to look at?
Well, I think it would just have to go over one from the books.
Okay, I mean, we'll have one, but it'll only be one type. So if you find an example of something that you want to look at, then we can do that. Okay. All right. Okay, so first off, I listed some things here at the top. Maybe you could just take like either take a picture of it, or I am going to upload this recording so you can refer back to it, but it might be easiest just to take a picture of the screen and just to make sure that you remember these things. So a lot of the things on here are either formulas that you need to have memorized or just skills that you need to be able to do for this next exam. And so that is what I have listed there at the top. And so we'll go through some examples, but I hope that you guys saw in the announcement that I did put an exam, like a practice exam, and there's an answer key to that too. So it might be a good idea to go look at that and also to just look at the study guide, because the study guide will give more types of questions, So if I'm saying on here, these are concepts that you need to know, then it would be a great idea to make sure that you keep working on how to solve them if you're kind of stuck on something like completing the square, because that's definitely something on here that you'll need to make sure that you know how to do on this exam, right? Or the use substitution, like was mentioned earlier. But yeah, some of these formulas you've got to have memorized, and so I'll talk about them as we go along too. So that's kind of what that first part is up there. Okay, and then remember that the exam will be in the testing center tomorrow, so Wednesday through Friday is when you can take it. So make sure to get registered for it if you haven't already done that. Okay, and there's going to be about 20 questions on the exam. I'm trying to remember how many there are for sure, but just around 20 questions, and you have 2 hours to take the exam. And just like always, you can use a scientific calculator on it, but make sure that you're always showing work too, because that's how I give partial credit. So it's important to be doing that. Okay. Any questions that you guys have just about the exam that I didn't cover or that you need more clarification on?
Will there be any word problems on the exam?
Yeah, the kind of word problems that there might have something to do like with the Pythagorean theorem, or some stuff where you are solving quadratics. So, and we'll work through a couple of them on here. So like this one is one where we're going to use the Pythagorean theorem. And then, and then there's another one here, like where you're solving a quadratic. So those kind of questions could show up on there, but there wasn't very many word problems this go around. But those are places that you did see word problems. Good question. Thanks for asking. Anything else? Okay, well, let's start working through these. So this first question is one where we're dealing with properties of exponents. And notice that we have some negative exponents there also, and so you've got to make sure that you keep your answers, like we need to make sure that they only have positive exponents in your answers, right? And remember, to make a negative exponent into a positive exponent, you flip it to where it is on the fraction. So if it's on the bottom and it's negative, flip it to the top, it becomes positive. If it's on the top and it's negative, flip it to the bottom and it becomes positive, right? So I always say, like, think about it as, where is it going to be happy or positive, right? And I use this this thing when I am in class, talking about how it's kind of like my kids, when we finished our basement, right? Some of them, just were all negative upstairs. They wanted their own space downstairs, right? And so they were negative when they were upstairs. So we flipped them downstairs. They became positive. Except my daughter, which when she got down there, she discovered that there's a few more spiders in the basement, even though we sprayed for them. And so she wanted to flip right back up into where she'd be happy. So just a silly way to kind of help you remember this. But let's look at this, because this one involves a lot of the properties of exponents that we talked about. And there's a lot of different ways that you can simplify these. So just because I do it in a different order than you do, that doesn't mean that you're doing it wrong or anything. There's just a lot of different ways to get there. Okay, but I'll explain to you why I'm doing it the way I'm doing it. So first thing I would say is I like to get rid of, if there's a negative exponent on the outside, I like to get rid of that first. And to do that, I need to flip everything on the top and everything on the bottom, right? So all of this on the top, just like it's written here, is going to go to the bottom, and everything on the bottom here is going to flip to the top. Okay, and that's going to make that positive out there. So let me write this down here. Let's see. Okay, so I have 5x to the -1 power. Notice that that didn't change. Exactly how it's written here is how I'm flipping it to the top, okay? Because I'm just working on that outside one right now to make it positive. And then y to the 4th. And then on the bottom, I get -4. So this is a question that I always get from people. I said, oh, but we flipped it downstairs, Becky. Doesn't that change to a positive? Nope, it doesn't. Okay, when we have exponents, they do. Coefficients never do that. So be careful with that. Okay, but so we're just rewriting it right now exactly how it is. All right, just flipped around. And then this is all raised to the 4th power now. Okay, all right, so again, for me, the next step that I like to take is try and get my variables together on the inside. And I also like to make sure that I'm looking at those negative exponents and flipping them to where they're going to be happy. So notice that my 5 and my -4, those coefficients, they're going to stay just like they are. Okay, this isn't a negative exponent, it's a negative coefficient, so it's going to stay there. All right, but this x to the -1 power is going to flip downstairs, and y to the 4th is perfectly happy upstairs, so it's going to stay upstairs. On the bottom, x to the 4th is perfectly happy downstairs, so we'll keep him downstairs, but y to the -2 is unhappy downstairs, so let's flip him upstairs to make him positive. All right, and again, I haven't used that power of 4 on the outside yet, so I'm going to keep writing that down. All right, so next, let's get those variables together. And also at this time, if these coefficients could reduce as a fraction, I'd want to do that, but 5 and -4, they don't have any common factors, right? So on the top, oops, I didn't need to make them quite that big. On the top, I have 5, And then y to the fourth times y to the second. When it's connected by multiply, we add those exponents, so y to the sixth. And then on the bottom, stays as -4, right? And then my x's, that's like x to the first power, add those together, I get x to the fifth. All right, and now I need to raise that to the fourth power. So some people, would rather distribute that power of 4 through to everybody first. And like I said, that's totally fine. You can do that. I like simplifying everything inside first and then distributing it, because then there's less to distribute. But it's totally up to you on how you want to do that. So, so on the top, 5 to the fourth power, so that's 5 times 5 times 5 times 5, is going to be 625. And then y to the sixth to the fourth, right? So a power raised to a power, this is where we multiply those together. So that's y to the 24th. And then on the bottom, I've got -4. I'm going to write this out to the side just to make sure everybody understands what I'm saying here. So I'm having -4 all raised to the fourth power. All right, and so when I have something like that, that's going to end up giving me a positive, because remember, if I have like a negative times a negative, that gives me a positive, and I have a negative times a negative, and then another negative times a negative, right? So 4 to the fourth power is 256, so now that is positive. And then y to the fifth to the fourth, or sorry, that's x to the fifth to the fourth. Again, we're going to multiply those together. So x to the 20th. All right, and then there is nothing more that we can do to simplify, so that would be our answer. Any questions on that? Make sure if there is questions that you have going along, please speak up, because if you have the question, somebody else, I'm sure, has that same exact question on this. Okay. All right, so number 2, write an equivalent expression using radical notation and simplify if possible. All right, so I'm trying to change that fractional exponent into a radical. And notice that the whole thing is inside parentheses, so that means the whole thing is going inside the radical. All right, well, what's inside the radical? Well, it's that 125a is inside there. Okay, and now I have this 2/3 power. Now, I'm going to write 2/3 over here just to kind of help you see. I had one student tell me that the way they remember where these numbers go is they think about the fraction bar. This is the ground, and the number in the bottom are the roots of a tree, right? And so this is telling you what kind of root it is. So that's going to be our third root right there. And then I like to raise it all to the second power like this. Okay, you could put it inside instead and then square it, but then it just makes that number really big, and then it's just harder to take the cubed root of. So I usually like to go about it this way. Okay, so now we can kind of split this up, and we're really doing like the cubed root of 125 and then the cubed root of a. All right, so what is the cubed root of 125? Just 5, right? Because 5 times 5 times 5 is 125. Make sure you know how to use this root button in your calculator. All right, scientific calculators will have a way to not just do a square root, but there might be a special button that is a cubed root, but then there might be another button where you can do any kind of root on it. So if you need help with that, like, stick around at the end and I can help you with that. Okay, now notice that when I take the cubed root of a here, there's not 3 a's, and so I can't bring like an a out of it. So I'm still stuck with the cubed root of a. All right. And now I still need to square everything here. So now I'm going to take 5 and square it. And this is connected by multiply, so I can do that. 5 squared is 25. And then when I'm looking at this next one, you know, that's, I mean, I really just have the cubed root of a squared. You can write it like that. Or if you wrote the answer as 25a to the 2/3 power, I would accept that also. Okay, so either of those answers are good on that. Okay, but just remember, like, it's just a 5 because 125 is a perfect square. I don't have like a to the third. If I had a to the third inside, then I'd be able to take that a out as an a, but as it is, it's still stuck inside, so that's why I had to do it this way. Okay, next one. We're dealing with properties of exponents still, but now these are fractions, but don't let that throw you off. Remember that just like when we did up here, when we had a power raised to a power, we're multiplying those fractions together, right? So if you need to like do a little side work, you know, I can go, okay, 3/5 times 6/25. All right, you can do that out to the side if you want to there. And so I still keep that power of 10, or I mean base of 10, I'm so sorry. And now I have 3 times 6 is 18, so that's my numerator. And then 5 times 25 is 125, so that's my denominator. So 10 to the 18 over 125 power. And that's really hard to tell that that is a power written that way, so let me rewrite it maybe like this. Okay. And that would be our answer there. All right, and just remember with fractional exponents, you know, just like if you had something inside here, you know, y to the 4th times y squared, when it was connected by multiply, we had to add those together. And so if you have to add it, then you'd have to get a common denominator in order to add those fractions together, or have a calculator that works with fractions, and I'm fine with that too. You don't have to show your work on that part, but make sure you're at least, you know, trying to show something, like help me know what you're doing to get your answer so that I can give partial credit. I don't just only put your answer down. That would not be acceptable. Like I did over here. I was just showing how I got that. Okay, so next thing, determine the domain. So on every single exam, we have had stuff about domain and range and stuff, and it's an important concept to have. Those of you that are going on to 1050 next after this class, you're going to see like you need to have that down really well. Okay, and so there's 2 things that you need to think about, 2 exceptions. So usually the domain is going to be all real numbers. So I'm going to write it down over here, maybe write this in your notes. So domain is all real numbers except when, so one exception is if you can't take the square root of a negative number, right? Because that gives us imaginary numbers. So we can't get a real number if we're doing that. So, so I'm just going to put can't take square root of a negative number. And then the other exception is we can't divide by 0. So if you don't have either of these two things, like say there's not a square root in the question that you're dealing with, like instead, if this said the cubed root, f of x is the cubed root of x plus 8, well, there's no exceptions for that. You can take the cubed root of a negative number and a positive number. So that would be all real numbers, okay? But if it's a square root like we have here, we can't have negatives inside there. And so the best way to kind of think about this is take what's inside that x plus 8, and it needs to be a positive number. And so to say positive in math, we say greater than or equal to 0. And really that's saying it's non-negative because it's including 0 as well. So if we're looking for non-negative numbers, which is what we're looking for, so we can take square root there, you're always going to put whatever's inside greater than or equal to 0 and then solve it. So on this one, we just need to subtract the 8 over. So x is greater than or equal to negative 8. And then we need to write our answer in interval notation. And so this is saying everything bigger and equal to negative 8. So I'll have a bracket, negative 8, and then everything bigger than it is everything going to positive infinity. So that would be our answer on that. And this was a different one. If it said a cubed root, it would be all real numbers. Okay, now again, if there was a fraction in it and there was a variable in the denominator, then we'd have to look and see what number is going to make us divide by 0, because that's the number it can't be. Okay. And there you better believe that on the final there's going to be stuff about domain and range. Okay, so if you've been struggling with it, let's get it down really good this time. Okay, so number 5 here, let's look at this. So it says multiply and simplify, right, this, and then make sure again that you remember all variables represent positive real numbers. And the reason why it says that is because if, like, say A was a negative 3, well, that's going to make that whole thing negative, and then we couldn't take the square root of it. So that's why we always put this little disclaimer in here that they're positive real numbers. Okay. Whoops, I meant up here though. I guess I did it. I moved down one. Okay, so what I'm going to do here is I'm going to kind of combine these together. Notice that you have to have the same index, right? They have to be the same kind of root in order to multiply those together. Yeah, please.
On the last question, it's probably a stupid question, but how did you know it was greater than or equal to negative or to 0? Like,
okay, so describe, like, if I asked you, how can we mathematically represent positive numbers, right? Because we can't take the square root of a negative number, so we need them to be positive. So numbers that are greater than 0 are what kind of numbers? Positive.
Okay.
Does that make sense?
Sorry.
So no, that's a good question. I think a lot of people get tripped up on that, so I'm glad you asked. Right? And so this way, it's always going to be greater than or equal to 0, because something greater than 0 is going to, is always a positive number. So, yep, so you'll write it. Good job. All right, and so on this one, right, they had to have the same root, and they're both square roots, so that's good. That means we can multiply them together just like they are. And so I'm going to write them as just one big square root, okay? And I'm going to write my numbers together and then my variables together. And I'm going to just kind of write this down in a way, so the book may have explained it differently than the way I explain it, but I tell students to make a little factor tree. So 2 is already a prime number, so it's going to go inside there just like it is. 10 is not prime. We could break it down to be 2 times 5, and then both of those are prime numbers. So we'll put those in just like that. And now if I write out my x's, I've got 5 x's there, and I'm just writing it out this time just to illustrate an idea here, hopefully to get in your mind what's happening. And then x squared, so 2 more x's multiplied together. And then since this is a square root, right, when there's no number written there, there's really like an invisible 2 there. So we need 2 of the same in order for those to come out. If it was a cubed root, we'd have to have 3 of the same number in order to bring them out, or variable, right? So here, I can take out a 2. I can take out some x's, right? So let's see. Right, so this comes out x times x times x, which is x cubed, right? Because these are all coming out just as 1x, these 2, so you have to have 2 of the same in order for it to come out as that number. Okay, so on the outside, things that got to come out of the square root prison is 2x to the 3rd power, right? And then still stuck inside the square root is that 5 and that x. And so all of that together is your answer. Okay, so kind of breaking it down and then trying to, pull things out in groups of 2 is the way I like to look at those. But if there's a different way that you like to do it, that's totally fine with me. Okay, I'm not expecting you to, show work in any specific way unless I tell you, like, solve this by completing a square. So that, that would be the very specific instructions. But unless it doesn't give specific instructions like that, do it whichever way you would like. Whatever way makes most sense to your brain. Okay, so now, yeah, please.
I am looking for this review worksheet that we're going through right now, and I can't seem to find it on the Canvas. I know I'm a little behind.
No, it's actually not on there. So here, why don't I'll send it in the chat right now, and then you guys will have that. Let's see. Yeah, what's going on?
Sorry, I just wanted to work through it parallel.
Nope, you're good. Okay, so let's see. This is hold it up here and gosh, what the hell? All right, here it is under study guides. Let's do, so let's try that one there, okay? So hopefully you guys can pull that up that way. All right. Okay, so let's rationalize this denominator. Now, to rationalize a denominator means that you need to get rid of the square root in the denominator, right? And so this is not very much room over here. I'm trying to decide if I guess maybe I'll just do it. And if I need to keep going over this way, I can. So first thing I would do would be separate these 2 apart. I can do that when it's connected by multiplication or division. So I'm going to put 10ab to the second, right, on the top, and then inside the square root, and then in the bottom inside the square root, I have 72 a cubed b. Okay. All right, and so now, whoops, I'm not going to put equals here yet because we're going to do something else at this point. All right, so, well, I guess there's a couple of different things you could do here. I can see that there might be some things that I could simplify, like things that I could take out. And so you could simplify it at the beginning of it, or you can simplify it at the end. Sometimes you end up having, if you do it at the beginning, you sometimes have to look again in the end to see if there's anything more that you can do, right? So let's look at this. So 10, remember, is just 2 times 5. So there's nothing there that can come out. But an A is stuck inside, but B squared, there's 2 B's, so that gets to come out. All right, so I've got a B on the outside, and then inside I have 10A. And then on the bottom, all right, so if I have that 72, let me put it over here, 8 times 9 is 72, and 8 breaks down to be 2 times 2 times 2, and 9 is 3 times 3. All right, so I can see that I have a 2 that can come out and a 3 that can come out. And so that means that a 6 is what's going to come out there. All right, 2 times 3, because when they come out, first thing they want to do is multiply. So 2 times 3 is 6. I get 6 that gets to come out. With my A's, right, 2 of those A's come out as an A, and then B is stuck inside. Okay, and so what else is stuck inside? Well, I've got this 2 over here that I didn't use, and I got an A and a B there. Okay, let me pause right there a second. Is that making sense to everybody so far? All I've done is just simplified the top, simplified the bottom, took out everything that I could there. Okay, and so now I need to figure out, what do I need to multiply by so that I can get rid of the square root? Well, when I multiply something by itself, right, like here when I had b squared, b times b, it got to come out as a b. So if I multiply this top and bottom by the square root of 2ab, right, exactly what it was, then it's going to make it so that I have no radical left in the bottom. Okay? And so on this next step, I am going to show it to you kind of multiplied out, and then do some reducing after. I don't want to skip steps here. So on the top, I have B on the outside, and then inside I have 10 times 2, which is 20, and then A times B, so A squared B. And then on the bottom, when I multiply these together, right, when I multiply square root of 2ab by square root of 2ab, right, that gives me, I'm going to show you right here, right, so 2 times 2 is 4, and then A times A is A squared, B times B is B squared. And so do you see that like everything gets to come out? All right, square root of 4 is 2. Let's see, oops, I forgot I have that 6a out there first. Okay, and then this simplifies to be just 2ab. That's the whole reason we multiplied it by itself, so that it could come out to be that same thing. Okay, and now I don't have any radicals left on the bottom, so I did rationalize it, but now I need to look and see if I can simplify anything more here. Okay, so let's look at the top again. With 20, let's see, I think I'll have enough room if I do it over here. 20 is 4 times 5, and 4 is 2 times 2, so that means a 2 gets to come out, but a 5 is stuck inside. All right, so I have a 2 comes out, and then an A also gets to come out, and I already had a B out there, and then stuck inside, we said that 5 doesn't have a buddy, so it can't go anywhere, it has to stay here. And then I still have that B that couldn't come out. Okay, so that's just simplifying the stuff on the top, if that's making sense to everybody. And then on the bottom, let's just, kind of, I can multiply these out, or at least, I might just break them down a little bit and see what I can, see what I'm able to maybe, divide out and stuff. So I have 6 times A times 2 times A times B. So I can see A's divide out, those 2's divide out, and a B divides out. And so that just leaves me on the top with square root of 5B, and on the bottom, just 6A. And so that is what I get for my answer. All right, so I've got to get rid of the radical on the bottom and then just make sure everything is all simplified up. Okay. All right, didn't really leave me very much room to do this one here, so I might just do number 7 over here to the side, just to make sure I can see it. All right, so when I am adding and subtracting radicals, they have to be the same root, but they also have to have the stuff inside the root the same, all right, in order to combine those together. I don't know, this one doesn't have a ton of work to show on it. Maybe I'll just put it here. So I can see that this is a like radical with this, because they both have square root of 7s. Now there's an invisible 1 in front of that. And then what I'm doing is I'm just adding those numbers together on the outside, because it tells me right here to add. So I have 6, and then I had to have that square root of 7 in order to add those together. So I keep that as part of my answer. And now I can combine those other two together because they're both 4th roots of 11. And so now I have -8 plus 9, which gives me a positive 1. You don't have to put this 1 here, but I'll put it just in case people are wondering what happened there. I combine those together, and then 4th root of 11. And that's all I can do with that one. Okay, so 6 square root of 7 plus the 4th root of 11 is what you'd come up with there. So remember, when you're multiplying, you just have to have the same index. But when you're adding or subtracting, not only does the index or the type of root have to be the same, but the stuff inside has to be the same. It's kind of like, like terms, like you can only add x's with x's or x squareds with x squareds, right? So we have to have those the same in order to add them. Okay, so this next one, we're rationalizing the denominator again. On one like this, I can see on the bottom that I have 2 terms. It's a binomial, right? 4 minus the square root of 5. When I have something like that, I'm going to multiply by what's called the conjugate. And so the conjugate of this is 4 plus square root of 5. So it's basically exactly the same as what it has here, except we're switching the sign in the middle. So if it started out as 4 plus square root of 5, then my conjugate would be 4 minus square root of 5. Right? So on here, we're going to multiply the top and bottom by the same thing. So 4 plus square root of 5. So on the top, all right, I'm just distributing that 5 through. So I'm going to just put this in parentheses here just to make sure it's clear. I'm taking that 5 and I'm distributing it through. So 4 times 5 is 20. And then I can only multiply stuff inside together and stuff outside together. And so really there's just a 1 here on the outside. So I'm doing 5 times 1 is 5. And then square root of 5. Okay. And now on the bottom, I'm doing FOIL. Okay, so make sure you're foiling it together. So 4 times 4 is 16. And then 4 times square root of 5 is plus 4 square root of 5. Then I have negative 4 square root of 5. and then square root of 5 times square root of 5. Remember, when we have the same square root multiplied by each other, it just comes out as that number, because that would be square root of 25, which is just 5. All right, now let's just finish simplifying this up here. Well, those middle terms are gone, right? Because those are just opposites, so they go to 0. And then 16 plus 5 is 21. And then we have on the top 20 plus 5 square root of 5. And then that would be your answer. Okay, questions on those? Other things that anything that I can clarify better for you there? Okay. All right, so in number 9, in order to solve square roots, we've got to get that square root part by itself first. So I need to start this off by subtracting the 3 over to the other side. Okay, I can't have anything else over there. It's going to make it so much easier for me if I don't. So I want to move that over. So that's going to give me x minus 3 equals square root of 5x plus 4. And now I need to I'm trying to solve for x, but right now that x is trapped inside a square root. So I got to think to myself, well, how do I undo square rooting something? Right? Just like in math, everything has its opposite. Right? To undo division, we multiply. To undo addition, we subtract. To undo square rooting something, we square both sides. Right? Because if I square this, it comes out as just itself, and it gets rid of that radical, which is what I want. But I can't just do it on one side. I have to do it on the other side as well. Okay? So here, be careful with this, because I can't just distribute that power through to them. This is telling me to FOIL. I need to do x minus 3 times x minus 3. Make sure you FOIL that out. Okay? And then on this side, well, that root, that square root and that square undo each other, and so then I'm just left with 5x plus 4 on this side. Okay, so let's keep going. I got to FOIL this together so that I can get everything over to one side, or I need to figure out how I'm going to solve it, but let's look and see what I have here. So x times x is x squared. X times negative 3 is negative 3x. Same thing there in the middle. And the negative 3 times negative 3 is positive 9. All right, and since I have an x squared that I'm trying to solve for, that means I'm going to have to factor this in order to solve it. So clear back when in that factoring chapter, at the very end of it, we talked about how to solve these. So we got to get everything over to one side and put the other side equal to 0. But maybe you want to simplify this up first here. So this is really x squared minus 6x plus 9 equals 5x plus 4. And now let's subtract the 5x over, and let's subtract the 4 over. Okay. And so that's going to give me x squared minus 11x plus 5 equals 0. Okay. Oh goodness, I forgot that this one came out to be like a crazy answer, and I actually changed it, but forgot to change it on here, because here this doesn't factor, and so then you end up having to use like the quadratic formula or something like that to solve it for x. But on the exam, I wouldn't give you something like that. Like this would factor out nice and neat. And so, like I said, I forgot that this one didn't work out very well, and so I redid it. So let me just maybe right over here, just so you can see what I mean, and I'll maybe work through this one a little bit faster. So if I have x plus 1 equals the square root of 8x minus 4. Okay, so everything, the square root part's by itself. So we're going to square both sides. So here, I've got to FOIL that. And then that just comes out as 8x minus 4, because those are opposite operations. They undo each other. Here, when I FOIL that, I get x squared plus x plus another x. So that's going to be 2x plus 1 equals 8x minus 4. And now we're going to subtract the 8x over and add the 4 over. So on this, I get x squared minus 6x plus 5 equals 0. And so now this one will factor better. So I'm thinking, what multiplies to be 5 that adds to be 6? Or sorry, adds to be negative 6, I should say. So that's going to be a negative 5 and a negative 1. Right? They both need to be negative so that I get a negative 6 there in the middle. But then to solve it, I set both of those equal to 0 and solve. So I have x minus 5 equals 0, x minus 1 equals 0, and then here I get x equals 5, and here I get x equals positive 1 when I do that. And you should always, always, always check your answers on these, just to make sure both of them work. And the easiest way to do that is just if you go back up to the original problem, specifically look and see if you're going to get like some kind of a, negative or something there. But I mean, you can kind of, do a visual check of it too, here. So if I put 5 in here, 8 times 5 is 40, minus 4 is 36, square root of 36 is 6, and then I put 5 in there, 5 plus 1 is 6. So that one works out. Same thing with the 1, 1 plus 1 is 2, and then when I put 2 over on this side, I got 16, wait a minute, what did I do? Oh, 1, sorry, 8 minus 4 is 4, square root of 4 is 2. So they both check out. But you should always check your answers whenever you're dealing with square roots, because you can't take the square root of a negative number. So you just always want to check them. So you could get what's called an extraneous solution. Okay, so I won't put something like this on the exam when you're solving this kind of a problem. It will factor really nicely here. And so that will be a lot faster there. I mean, because like I said, on this one, you'd have to use the quadratic formula. And that's not like that's a bad thing. It's just, I just didn't want you to think it was going to be that difficult on the exam. Okay. Okay, so number 10. You want to buy a 53-inch flat screen TV, and you can see on the box that it is 28 inches tall, but it doesn't say how wide it is. You only have room on your wall for a TV that is 43 inches wide. Determine the width of the TV and if it will fit on your wall. Okay, so remember that when you are measuring any kind of a screen, whether it's a monitor or a laptop or a TV, the diagonal is what is the length that they're giving you, right? So when you go to the store and you say you're buying a 53-inch TV, that 53 inches is going from corner to corner. Okay. And then we know on there that it's 28 tall, but I don't know how wide it is. Okay. Okay, so what are we going to use to solve this? You know?
Wouldn't you just solve for that triangle there, assuming that is going to be a right triangle? Well, I guess not a right triangle, but
yeah, it is a right triangle. Like this is a 90-degree angle, which
I don't know the surface area. Is it?
That's the Pythagorean theorem.
Yeah, so you're going to do the Pythagorean theorem. So a squared plus b squared equals c squared is what we want to do. And remember, c, that number that's over there, or that c that's by itself, is always our diagonal length. And then a and b, it doesn't matter which one we put where, right? So I'm going to put x in here. So I'm going to have x squared plus 28 squared equals 53 squared. So again, really important that that diagonal length is the one by itself. Okay, otherwise you're going to get totally weird answer on that. All right, so now let's just use our calculators a little bit. 28 squared, so 28 times 28, what do we get there? Oh, 784.
784.
Okay, and then 53 times 53.
2,809.
All right. And now we need to get the x by itself, right? So next step is I'm going to subtract that over. So I'll write it up here like this. So x squared equals the 2809 minus our 784. So I got to get that over onto the other side. What do I get when I subtract those two numbers? Should come out
2,025.
Yep, 2025. And then how do I undo squaring something? Got to square root it.
Square root it.
Yeah.
Sorry.
You're good. So then put, in your calculator, the square root of that. And what do we come out with?
45.
45. Okay, so it's going to be 45 inches. Is it going to fit on your wall?
No, sir.
No, it won't. Will not fit. Okay, because you only had 43 inches. So the thing that I want to, just make sure that you see on this is like you're not using that 43 in the Pythagorean theorem, right? So that's why I say like always draw a picture of what you have, right? What's given to you. And then this last part is just to check it against this. Well, 43 is smaller than this, so it won't fit. All right, and make sure you remember to use your labels and stuff like that, like inches or feet or, whatever the units might be. Okay, number 11, you're going to use the midpoint and the distance formula in order to figure out both of those. So we're using the same points on both of them. But let's go ahead and I'll put over here, we'll do the midpoint first. So the midpoint formula, so think about like if you were trying to find, exactly, the middle of something, it's like you're taking the average of our x values and the average of our y values. So when you're trying to find the average, you add the numbers up and then divide by how many there are. And so in this one, that's why the formula looks like this. It looks like an ordered pair because it is. We're going to take our x values, x1 plus x2, and divide it by 2, right, to get the average of our x values. And then you'll do the same thing with the y's. Take the y1 plus the y2 and divide by 2. So, and you might want to, label over here what you see as what. So like if this is x1, y1, x2, y2, right? Because each ordered pair is made up of an x and a y. All right, so our x's added together, -8 plus 6 divided by 2. And then our y's added together, -5 plus a -1 all over 2. And now let's just simplify this up completely. So on the top, I get -2 over 2. And then on the bottom, -6 over 2. And so this will still simplify more. So I get -1, comma, -3. And so that is the point that's smack dab in the middle. So if I was to draw this on a grid, right, they had like, you know, a point here and a point here. Well, this midpoint better be smack dab in the middle of those 2 points. So you can kind of check it by drawing a graph of it and seeing if it looks like, you know, where it should be, you know, halfway in between the 2 points that are given. All right, and then the other part is the distance formula. So remember, these formulas are not going to be given to you, so you need to make sure that you have that, you know, you have these memorized on here. So the distance formula is d equals the square root, so it's a big, huge square root, right, of your x values being subtracted this time. So they're added up here, but here they're subtracted. And I think the book writes it as x2 minus x1. Doesn't matter which order you're doing it in because you're squaring it after that, which is just going to make it a positive number. And then plus our y values subtracted from each other. So y2 minus y1 all squared. Okay, so that is the formula. And now again, we're just plugging those numbers into it. So if you don't have this formula memorized, it's going to be really hard to put those in. So when we put those in there, we've got d equals the square root. So I've got 6. And then x1 is -8. So I'm doing minus a -8. So be careful with your negatives there. Squared. Plus y2, which is -1. Minus y1, so minus a -5 all squared. Okay, well, if I'm subtracting a negative, I'm really adding these together, right? So I'm going to just rewrite it like this. So here I get, so I get 14 squared plus 4 squared. And now I need to, you know, just keep going here on this. Simplify everything inside first, right? So 14 squared, so 14 times 14, and then 4 times 4 is 16. And then when you add those together, it should be 212. And then it does tell you on here, to give, you know, exact and approximate answer. So this is the exact answer. And I know this looks kind of weird. So with the square root around it, this is one of the answers. This is our exact answer. Right? But if somebody asked you the distance of something and you said, oh, the distance from here to there is square root of 212, they'd look at you like you're crazy, right? So that's why we use approximations on this. So you'd want to put it into your calculator. Square root of 212, actually, that 212 I think breaks down. Let me get rid of this so I can, because we want to make sure that it's, let's see, because 2 will go into this. So again, like in my mind here, I'm thinking of, you know, a factor tree. So if I do that, that's going to give me, goodness, what am I doing there?
106.
Yeah, thank you.
No problem.
And then 106 will still, 2 will go into that, right? And then 53 is prime, so it stops there. So a 2 gets to come out and the 53 is stuck inside. So this is how you'd want to write your answer. 2 square root of 53 is our exact answer. Okay, but now just put square root of 212 in your calculator, and on some of your calculators it might give that back to you, or it might give it to you in that simplified form already, but it won't give it to you as a decimal. So if you look, there's like a button below the enter button that kind of looks like this, where there's like 2 arrows away from each other. If you click on that button, it changes it to a decimal. And same thing on your calculators, like if something is a fraction, it changes it to a decimal, or if it's a decimal, it'll change it to a fraction by using that button. It's just this little toggle button. Okay, and it says to, oh, I didn't say where to round it to on the exam, but it will tell you to round to the nearest tenth or something. So this one would be 14.6. Is that what you guys got? And it didn't give me, like there wasn't any like units or anything like that to use. So we'll just leave it at that. 14.6 units. And this is the approximate answer. All right, questions there? So this was number 11. I just did it over here so I had more room. Okay, we're getting there. But please keep speaking up if you have questions. Don't just keep them to yourself. If you have a question, somebody else in here has that same question, I'm sure, and they'd appreciate you asking, so ask away. All right, so with this, all right, we have a binomial multiplied by another binomial, so we're really FOILing here. All right, just an acronym. I mean, some teachers absolutely hate that acronym, but if it helps you to remember, what you have there, you're just multiplying the first, outside, inside, and last. So 3 times 4 is 12. 3 times 5i is just 15i. Right, we're just treating I like it's any other variable at first, so don't let these i's throw you off. Okay, then in the middle there, negative 8i, and then the last one's multiplied together. That's going to give me negative 10i squared. Okay, so we can see that we've got some like terms that we can combine together there. So 12 plus 7i. All right, but remember that I squared, one thing that you need to have memorized, that you need to do, I squared is the same thing as negative 1. All right, so that's something you need to make sure you know. And I is the square root of negative 1. All right, so if you know those two things, that will be really helpful on the exam. And so really here I have negative 10 times a negative 1, right? Because that whole I squared is being replaced with the negative 1. So that's really just going to be plus 10 here. So 12 plus 10 gives me 22, and then plus 7i. And notice it says to write your answer in the form of a plus bi, so that means that you're writing the real number part first and the imaginary number part second. So like that. Okay, so just FOIL it out, and then when you get to the end, if you see that there's an I squared, then replace that I squared with a negative 1 and simplify it some more. Okay, so don't let imaginary numbers like freak you out or anything like that. Just treat them like most variables, and then the only other thing that you got to know are these two things. Okay. All right, so in this one, it says solve by completing the square or by using the quadratic formula. Well, later, we are going to be doing completing the square on a circle, so I'll just use the quadratic formula to solve this one. So when I'm doing this, I can't use my my coefficients like they are here. Remember, I have to get everything over to one side and put the other side equal to 0 before I can figure out what my a, b, and c are. So I'm going to have x squared, and I need to minus that 8x over, so minus 8x plus 26 equals 0. And now I can see what my a, b, and c are. So a is 1, b is negative 8, and c is 26. And so I'm going to just put those numbers into the quadratic formula, and the quadratic formula, you can write it here, is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay. So there's like a little song that maybe some of you have heard. That's what I was singing. It's like to Pop Goes the Weasel. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. All right, just any way that you can get to make sure that you have this memorized, right? You can look up some of those songs on YouTube or something if you want to, practice some of those to make sure that you can get it down. All right, so if I'm putting my coefficients in here, right? So negative b really means the opposite of b. So the opposite of negative 8 is positive 8. So x equals positive 8 plus or minus the square root of negative 8. Make sure you put your negative 8 in parentheses like this. Negative 8 squared minus 4 times a, which is 1, times c, which is 26, and then all over 2 times 1, which is just going to be 2. Okay, so just plugged in the numbers so far. Now I need to simplify. When I simplify, I'm going to start inside that square root there. So that's going to be the easiest place to start. Get this all together. So negative 8 squared, negative 8 times negative 8 is 64. And then a negative times a positive times a negative is going to be a negative, right? What's 4 times 26? We have that.
104.
What'd you say? 104?
104, yeah.
Yeah. Okay, and then all over 2. All right, so let's get those together. What's 64 minus 104?
Negative 40.
Yeah, negative 40. All right, so I see that there's a negative inside there. I'm going to get rid of this stuff right here since I don't really need that. So since there's a negative, right, when I have the square root of a negative number, that means I'm going to have an I that I need to take out of this. And I can also see, like with 40, that's 4 times 10. All right, so I can take a square root of 4, which is 2. So 2 is going to come out. So when I write this out again here, so I'll have 8 plus or minus. When I simplify this right here, the I is going to come out, but a 2 is also going to come out. So 2I, and then stuck inside is going to be a 10. And again, I'm just doing this in my head here, but hopefully you're following me what I'm doing. All right, so this 2 gets to come out, and the 10, the 2 times 5, is still stuck inside there. Okay, and then all over 2, but on this one, when you're dealing with i's, I want you to break this up so you put this over 2 and this over 2, because we need to treat those as 2 separate fractions, because now we need to reduce those fractions as well. So 8 divided by 2 is 4. And then that 2 divided by 2 divide out to be a 1. So I get 4 plus or minus I square root of 10. And there's nothing left in the denominator anymore because I simplified all of that. So that would be my answer. And it will also say, if it's imaginary solution, to write it in the form of a plus bi, meaning the real number part first, and then that second. Now, on your homework, you had to write those separate, right? So we have x equals 4 plus I square root of 10, and then x equals 4 minus I square root of 10. And some of you were putting I behind it, which is totally fine to do. Just be careful that you're not accidentally putting the I under the root, because that would be wrong, right? We can't have 10 square root of 10 I like this, because it's not inside there. It's the square root of 10 and then I out here. Okay, but I don't care. Like if you leave it with a plus or minus sign on the test, I'm totally fine with that. If you write them separate like this, totally cool with that, right? So you just decide how you want to write those answers out there. Okay. All right. Should have given myself more room on here. I'm glad I have some room out here to the side. Okay, number 14. So this is saying I'm going to need to write a quadratic equation given these solutions. All right, so I'm going to write this up here again. So x equals 2/3, and then x equals -1/5. And so when I'm doing this, I'm kind of like undoing the process when I was factoring. So let me go back up here to that one that we did. Remember here, so if I have, these are my two solutions, 5 and 1. And then I needed to get, like put them equal to 0, and then get it so that they're multiplied together. And after I multiply them together, that's my equation that I'm looking for. All right, so I'm just kind of going backwards on these steps to get back to what this was. And so that's what I'm trying to do here. Now with this, with the fraction here, there's a couple of different ways to deal with it. I like to just get rid of my denominator, and I can do that by multiplying both sides by the LCD, which is 3. All right, so that gives me here just 3x equals 2. And then I need to subtract that over to the other side so I can get it equal to 0. So 3x minus 2 equals 0. So all I did here was just got rid of the denominator, right? So again, on this one, I don't want to deal with a fraction here. So if I multiply both sides by that denominator, then I get 5x equals -1. And then I get it all over on one side to put it equal to 0. So 5x minus 1 equals 0. And then those two things that I have set equal to 0, that's what's going to go inside my parentheses. And those are the two things that I need to multiply together to get my equation that I'm looking for.
I have a silly question.
Oh, don't say it's silly. Just say I have a question. It's good.
I don't understand the simple stuff. This is like the biggest thing I have a problem with.
That's
I
okay.
understand the rest of the math.
Yeah, you're good.
How did you get x equals 2/3 and x equals -1/5?
So that was just given here.
Oh, I'm looking at number 15. Never mind. I'm
Okay,
sorry.
yeah, sorry. I didn't have enough room there
No.
on 14, so I just wrote it over here. So no,
Sorry,
that wasn't a
thank
silly
you.
question. It was just, there it is, right? So, okay. All right, and then we'll be done once we FOIL this together and just get our like terms together. So we get 15x squared, and then minus 3x minus 10x, and then plus 2 equals 0. So got those middle terms I can get together. So 15x squared minus 13x plus 2 equals 0. And that would be what I'm looking for, because I'm looking for an equation, right? And so again, I'm going to go back up here again so you can kind of see what we did. All right, we worked backwards. All right, we had our answers on that one. Since they were fractions, I had to take an extra step in there. But you want to get it equal to 0. Once you have those two things equal to 0, put them in parentheses, multiply them together, and then get what you started with. So whenever there's a way to do something in math, there's always a way to undo it. And you'll find, like in math, that's what we do a lot of. Like we do it, and then we undo it. And then we do it, and then we undo it, right?
Wouldn't it be 1 if you're sending it over?
That's exactly what I was going to say.
Oh,
Does it
wait a
stay
minute.
-1? It should be positive, right?
It should be +1. Thank you
Okay.
very much. Yeah, I need to put that over. Does everybody see what he's saying there? When I move that over, I should have made that a +1 instead. So that just changes this. So I have That's going to be a positive 3 there. And then I'm going to have a negative 2 here. Okay, let's see, so 15x squared. And then that's going to be plus 3x, and that's minus 2. So now we've got to subtract those guys. So we get negative 7x, and then minus 2. Get rid of that addition sign 2 there. Thank you for noticing that. Sometimes I get a little bit ahead of myself there. Does that look better?
Awesome.
Great. Okay, we're getting there, guys. Now we said it'd hopefully be done by 9, so we'll try and do as best as we can here, okay, to get it done by 9 for you. All right, so on this, it's asking us to do a few different things, right? Find the vertex, find the axis of symmetry, find x and y intercepts, and then the minimum and maximum value. And then we want to make sure that we graph it on here. Well, this is already in vertex form, so the vertex is easy to pick out of this. And that's going to be, so you do the opposite of what's inside the parentheses there. So it's a positive 5, and then this one stays a negative 3. Okay. And then the axis of symmetry always lines up with whatever our x coordinate is. And when it's a parabola, we're going to have a straight up and down line. So my axis of symmetry, the equation of that, is going to be x equals 5. Okay, so it's always taken from whatever my x coordinate is there. Now to find my x and y intercepts, be really careful. I get a lot of times people saying that the y-intercept is negative 3, and that's not the case because this isn't in standard form, right? So in order to do this next part, to find the x and y intercepts, it's going to be best to change this to standard form. So let me put this over here. So if I have 2 times x minus 5 squared, which really means x minus 5 times x minus 5, and then minus 3. All right, so I need to FOIL that stuff out. So I get x squared, and then I get negative 5x, and another negative 5x, so that would be negative 10x. And then negative 5 times negative 5 is positive 25, and then minus 3. So I didn't really need it. Yeah, let's see. Oh, let's do this. I need to have that. Because notice that it was 2 is going to be multiplied by all of this stuff there. So that's why the 2 is in parentheses next to these guys. So now let's distribute that through. So I get 2x squared minus 20x plus 50 minus 3. And then when I combine that together, 2x squared minus 20x and then plus 47. All right, so on this, what did I do? It's not right. What did I do? Oh, I know what I did. Again, I changed it because this goes off the graph. And so on the test, it will be something that you can actually graph on there. So I'll just make these, these won't be going by 1s on here. I'll have to, have them go by by 2s or 5s, or probably 5s in order to get that, right? Because my y-intercept now is whatever this number is, that constant term there. Okay, so my y-intercept is going to be 0,47. All right, and then my x-intercept, I would have to, factor that. And actually, you know, in this one, you could graph it without knowing the x-intercepts. And if I give something like this on the exam, I'll make it so like the x-intercepts like are easy. Well, sometimes I guess in the past I have done it where you have to use the quadratic formula to do it. So we can do that. So this is our y-intercepts. All right, and so to find the x-intercepts on this, I can let y equal 0 and then solve for x on this. So I just need to I can go to this part right here and then try and put that in for like, so my a is 2, my b is negative 20, and my c is positive 47. So it's going to be kind of some nasty numbers to put in there, but luckily you've got your calculators, all right? So x equals negative b, so the opposite of that's positive 20, plus or minus square root of, b squared minus, let's see. So b squared is going to be negative 20 all squared. Keeps kind of glitching here when I'm writing. Minus 4 times 2 times 47. And then all over 2 times 2. Okay, so if you write this all out so I can see what numbers you're putting where, I'm fine if you do most of the rest of this in your calculator. Okay, so don't have to show like every single step out if your calculator will do that. So let's see, that's 400. And then does anybody have, what's 4 times 2 times
386.
Thank you. And then all over 4. So what do I get here? 20 plus or minus what?
Okay. 16.
Is that 16? I thought you said 386, did I?
I did.
Oh, okay. Okay. All right. Yeah. 16 and then all over 4. And so what's the square root of 16? Sorry, that looks really bad.
That would be 14. That's where I did the math wrong, right there.
Okay, so it wasn't.
It would be 20 plus or minus the square root of 14.
Okay,
it is
you're right. Okay, it was 386.
That.
Okay, making sure that was the right number there. Okay, sorry, that really looks bad now. Okay, so 14. And so, and really you can just, I mean, from here I would just put it into your calculator, right? 20 plus the square root of 14 divided by 4, and then 20 minus the square root of 14, all divided by 4. Because you can't really graph those, you know, you don't know where those are at. We need a decimal approximation to be able to do that. And I didn't bring my calculator in here. So what's 20 plus the square root of 14, and then all divided by 4? I get here as a decimal approximation.
So the plus would be 8.74.
Okay, so let's just put 8.7, what everybody got, and then 20 minus the square root of 14. Wait a minute, that's right, okay.
And then minus would be 4.06.
Okay, so I'll put 4.1. All right, so then we can just graph each of those different parts, right, to be able to make this graph. Now, obviously, that's going to go off our, you know, like the y-intercept is going to be clear up here somewhere. I'm just going to do that. The vertex over 5 and negative 3. So maybe I'll just kind of go like this. It's going to be about here. Then my x-intercepts are going to be like this. And so, and my axis of symmetry would be going right through there. So sorry, it's not to scale. I'm not moving by ones here, right? Because it was too big for that 47. But do you see, like, this is the shape of it. So it's going to be kind of like a U shape like this. So hard to draw on here. I do so much better on the board than I do on these silly things. But yeah, so the axis of symmetry is right here, which is that line x equals 5. All right, and then we have those other points that we found on there. Oops, I should have went up through this point here. Oh my goodness, this is so hard. Okay. Sorry, that looks a mess. Maybe I can get rid of it. I don't know. Sometimes it erases a lot. Oh, that's all right. Okay, so that's kind of how those are, that problem is. Okay, I guess here's another thing that we have. So a firecracker is fired up into the air. Its height is given in feet, and then the t is the time in seconds, and they give that equation there for us. So what is the greatest height of the firecracker? So let's think about this. So hopefully, you know, in doing that activity, that Desmos activity that you did, you got kind of used to, you know, doing some of these things and understanding that, oh, when that first coefficient is negative, that means I have an upside down parabola. And so that means that the vertex is going to be a maximum. Okay, so I need to find the vertex in order to find the maximum. So it's not going to say find the vertex, it's going to say find the maximum height, right? Which means it wants you to find the vertex. So you got to keep those two things in mind here of what's happening. Okay, oops. Well, that's also part of the vertex, but I meant to write this here. Okay, so what is the greatest height of the firecracker? Okay, so on something like this, you can, you know, try to factor it out and stuff and see, you know, if that will work. And if it doesn't, then you might have to, you know, go and use the, you know, different, like the vertex formula and the quadratic formula and stuff. So on this, it looks like we can factor out a negative 16 on there, but oh, let's just do the vertex. So the vertex formula is, so the x is negative b over 2a, and then the y, to find y, you just plug x into equation. Okay, so the height, let's see, so if I do, the height is going to be that second thing that I find though, right? And then t is the time. So if I'm doing this, let's figure these out. So x equals negative 96 over 2 times negative 16. All right, I'm just using these, the a, b here. All right. Negative 16. Okay, so that's negative 96 over negative 32, which gives me what? Should come out nice and neat.
Negative 3.
Yeah, negative 3.
Or positive 3, sorry.
Yeah.
Negative on both ends.
Yeah, so this is 3 seconds, right? And that's a good thing that you said negative, because hopefully, like when you write down your labels after it and you saw negative 3, right? If you accidentally did that, you're like, wait a minute, it's got to be positive, right? Because seconds are not negative, or time is not negative. Okay, and then now we'll take 3 and plug it back into our equation to figure out what h is. So h equals negative 16 times 3 squared plus 96 times 3 plus 32. So here I got to do negative 16 times 9. Make sure that you do that exponents first on that. 96 times 3 plus 32. And then negative 16 times 9 is negative 144 plus 288 plus 32. So that's just going to be 144 plus 32. So it's going to give us 176. All right, and 176 feet. All right, that's what I was talking about with height, because h, my h that I'm finding is the height. Okay. And it would make, I mean, and so that's why I, found both of these, but then make sure that you're putting it in the right place, right? The greatest height is 176 feet, and the time it takes to get to that maximum height is 3 seconds. So just be careful with those, right? Because it wouldn't make sense that it's only going to go 3 feet in the air and that it would take 176 seconds to get there. So, make sure that you're kind of thinking about it as you're, that you have your labels right on those. And then the last thing says how many seconds until it reaches the ground. Well, again, remember when the, what is the height of the ground? Well, that's when h is 0. So we're going to put 0 in place of h here and then solve it. So 0 equals negative 16t squared plus 96t plus 32. All right, and then you can see if this factors nicely. Negative 16 can come out, leaving t squared. And then what is that? Is that 6? And then plus, minus 2. Oops, did I do that wrong? Let's see. Yeah, minus 2. Okay, and then when I try and, factor that's not going to factor, so I'm going to have to put it in the quadratic formula again to get that. So A is 1, B is negative 6, and C is negative 2.
So when you do the quadratic formula,
actually,
that equation.
Yeah, we actually have to go back to the beginning. So we have to use these numbers up here, actually. So
I was going to ask what you do with the negative 16.
Yeah, no, you can't use it like that. So I always like to check and see if it does factor, because if it does, then that's a lot faster way to do it, but it won't. So I'm just going to get rid of that. It won't factor, and let's just use it. You got to have it just as those numbers as they were before. So A equals negative 16. B equals 96, and C equals 32. And then put those into the quadratic formula.
Is equal negative b plus or minus the square root of.
Yep, so x equals negative 96 plus or minus the square root of b squared minus 4 times negative 16 times 32 all over 2 times negative 16. And when you do simplify that up, I did figure this one out, and you get 2 different answers. You get a negative 0.3 and 6.3. All right, and these are seconds, so it doesn't make sense to have negative amount of time. So this is an extraneous solution, and so we throw it out because we can't have negative time, and so 6.3 seconds is our answer. Okay. So you'll have to I just don't want to take a bunch of time simplifying that, but go ahead and try that on your own there, making sure you know how to simplify that quadratic formula. But Okay, we've got 3 more here. So number 17, find the center and the radius and then graph the circle. Well, in order to find the center and the radius, we've got to change it to standard form. And to change it to standard form, we need to complete the square. So remember, standard form looks like this. X plus h all squared plus y, whoops, I meant minus. X minus h all squared plus y minus k all squared equals r squared, because the way they gave that formula to you, right? And so to complete the square, we got to get our x's together and our y's together, and we're going to start by adding that constant term over to the other side. Okay, and so I'm going to rewrite this way. So I'm going to have x squared, and then get my other x next to it, plus 6x plus blank, right? And then I'll come back to that in a second. And now get my y's together, so plus y squared plus 4y plus blank equals 12, positive 12 there, right? Plus the green blank and then the blue blank. Kind of ran out of room here, but you gotta, I'm just color coding it just to make sure you see where those numbers are coming from. All right, so I've got to complete the square on this to figure out what goes here, and whatever number I add to one side of the equation, I got to add that same number to the other side. All right, so to complete the square, remember we do half of the middle term, so I'm going to take 6. Oops, let's see, I meant to put this in green. Ooh. Okay, so 6 divided by 2 is 3, and then I take 3 and square it, and that gives me 9. So 9 is the number that needs to go there, which is also 9 there. Okay, and then the number that I put here, I'm going to take half of that middle term, right? So 4 divided by 2 is 2. And then 2 squared is 4. So 4 is what goes in both of these blanks. Okay, and now we got to get it looking like this. So we made these into perfect square trinomials so that they will, look like this. Because if I factored this, just like it is here, say what multiplies to be 9 that adds to be 6, well, that would be 3 and 3. Well, and another way I can write that is x plus 3 all squared. All right, so whatever you found half of that number to be in the middle is always the number that you're going to get there. Okay, and then on this one, so kind of similarly, half of that is 2, so y plus 2 all squared. And then if I add these together, 9 plus 4 is 13, plus 12 is 25. Thought I did that in a different color. Okay, but 25 can also be written as 5 squared. Okay. So my center comes from these two things here. So my center, and since they're in parentheses, whenever I'm dealing with like parentheses, I say like insiders or liars. So it's like you're doing the opposite of it. So the center isn't at 3, 2, it's at -3. It's like the opposite of that there, and -2. And then the radius is the square root of that number, which is 5. Right? And this one could be written out that way, but maybe if it's not a perfect square, then you're taking the square root of that number to find it. So maybe I'll just kind of show that here. Okay, and so then if I graph it, So over -3 down to, well, let's see, I'm going to use these as so 1, 2, 3, and down to, so I'm going to go there. And then I need to go 5 in each direction. So 1, 2, 3, 4, 5. And then I just need to connect those together. And whenever I do this on here, it always looks more like more like a square than it does a circle, but or maybe a rugby ball or something. Anyway, but you get the idea. It's hard for me to do it on here. Okay, I'm going to stop playing with it because you get the idea. All right, and I'm not going to be like really picky either. Like you can see my drawings are not great. I'm not going to be like, oh, that's not a circle. All right, if I can see all the other stuff that you did to get there, then that's great. Okay, number 18. Before we can solve this inequality, we got to get everything over to one side and put the other side equal to 0. And with inequalities, it makes it so much easier if you get everything to the left side. So I'm not going to move it to the right, I'm going to move it to the left. So that means I'm going to add the 15x over, and I'm going to add the 56 over to the other side. So that's going to give me x squared plus 15x plus 56 is greater than or equal to 0. Okay. And then this is going to factor. So what multiplies to be 56 that adds to be 15? It'll be 7 and 8. All right, but really what I want to know is when it does equal 0 exactly. All right, so it equals 0 at -7 and -8 when x is -7 and x is -8. Okay, and so on this, there's so many different ways that this can be taught, and I mean, for me, like I think about it and say, okay, this is a parabola. The leading coefficient is positive, so that means I know it's a right side up parabola. Okay, so I know it's going to be kind of like this U kind of shaped parabola like this. And it's going through, like the x-intercepts are -7 and -8. So that's where the parabola is going through at those points. So I'm going to just kind of draw this out here. So it's going through here, and it's a parabola kind of looking like this. Okay, now I want the stuff that is greater than or equal to 0. What kind of numbers are greater than 0?
Positive.
Positive number.
Positive. So that means we want the stuff that's above the x-axis. So that's this part and this part that's above the x-axis. I want to know what x values those hit. So basically, it's going to be everything except the stuff that's in between those two, right? That's the only part. Let me draw a picture here. So this green part right here is the part we don't want. We want that red part. Okay, and so when I'm thinking about how to write that out, well, this is going clear out to -infinity for my x's. Let's see, try and write it over here. So my answer is going to be -infinity to -8. So that's what I have there. And it includes it because it has that equal to part on it. If it didn't, then we'd put a parenthesis, but since it has the equal to part, we'll put the square bracket. And then it skips the stuff in between 7 and 8, or negative 7 and 8, and now we have from negative 7 to positive infinity. And that would be your answer. And you know, on the videos, they may have shown you like a chart to do, like with, you know, like positives and negatives and stuff like that to figure things out that way. I'm fine with it if you do it that way. If you understand what I was just saying here, that what you're looking for, all right, if it said that we wanted the stuff less than or equal to 0, then it would just be that green part, the stuff in between negative 8 and negative 7. But since it's greater than 0, we want the stuff above the x-axis. So that's the majority of it.
Do you always read graphs left to right?
Yes, that's a good question. Always, always, always from left to right.
Okay.
Yep. And so when we're writing out interval notation, that's why it always goes from left to right. Yep. Okay, one more problem here, and this is a U substitution one. Okay, and so on this one, and I'm not going to do one of the really crazy U substitution ones on the exam. There definitely will be one on the exam though. So if you've struggled with those, maybe go back and, you know, look at them a little bit more. Maybe something like this, or, you know, I'm not going to have like the ones where you have to like do the square root or like weird fractional exponents or anything like that. So something like this would be more of what I'd be looking after. Okay, so when I'm using U substitution, the first thing that I do is I like rewrite this because I need this to look quadratic in nature, meaning I need to have something all squared. All right, minus, you know, something. Let's see, so let me go here. So what squared is going to give me x to the 4th? Well, that would be x squared, right? X squared squared is x to the 4th. And then here, 4 times x squared. I'm just writing it like this so we can see where we're going to put those u's in. And then minus 12 equals 0. So whatever this middle term is there, that's always going to be telling you what you're going to be using for U substitution. Yeah, on these types of problems that you're doing here. You'll do U substitution in a lot of different ways, like if those of you that are going on to calculus and stuff like that, and that's not always true. But for these ones that are quadratic in nature, that will be true. Okay, looking at this. So I'm going to let U equal x squared. So everywhere I see an x squared, I'm going to put a U in place of it. All right, so really here I have U squared minus 4U minus 12 equals 0. And now that doesn't look so difficult to factor, right? So on here, that's what I want to do next. What multiplies to be negative 12, that adds to be negative 4.
Wait, why 4 squared?
Not sure what you mean. 4
Like
squared?
when
This is a
you're
U.
rewriting it?
This is a U.
Oh, sorry.
Yeah, no, that's okay. I can see why you would think that that was a 4. Yeah, let me make a little tail on those U's a little bit better, so they look more like U's. All right, so this is a U and U. That's what these are also. Okay, so what multiplies to be negative 12 that adds to be negative 4? Well, negative 6 and positive 2. And then set both of those equal to 0 and solve. So U equals 6 and U equals negative 2. but we didn't want to know what u was. We wanted to know what x was. All right, so we took this out. We took the x squared out to make it easier to factor. Now we've got to put that back in. All right, so I'm going to put x squared back in to both of these. So I have x squared equals 6. And then here, in place of that u, right, putting the x squared in place of it, right, so x squared equals -2. Okay, now how do I undo squaring something, right? I'm trying to solve for x. Right now I have x squared. What do I do to undo squaring?
Just take the square root.
Square.
Yeah, square root it. All right, we'll do that on this side also. So here, when I do that, I just get x equals, now don't forget, you've got two answers on this, right? Plus or minus the square root of 6. All right, so that's two answers. That's x equals square root of 6 and x equals negative square root of 6, right? That negative's on the outside. Okay, here we've got a negative inside a square root. So when we do this, we get x equals the negative that's there. Sorry, it's hard to see with my root around it now, but there was a negative inside there. All right, that's going to come out as an I, and then the 2 is still stuck inside there. So I've got I square root of 2. And again, I've got to do the plus or the minus, all right, whenever I'm solving for these. So x equals I square root of 2, and x equals negative I square root of 2. Okay, now I ended up with 4 answers. Okay, and I do have 2 of those answers that are imaginary, and that's just fine. But look at here. This is something that I try and point out when I'm like teaching this class. See this highest power right there is a 4? That is telling me how many answers I should end up with. If my highest exponent was a 3, I would end up with 3 answers. And some of those could be imaginary solutions, right? If the highest power was a 2, I'd end up with 2 answers. If, the highest power was a 5, I'd end up with 5 answers, and so on. Okay, so that's telling you how many solutions you will come up with. And so I got 4. That checks out that I should have gotten 4 there. Okay. Okay, well that was the last problem there, and I know we've been here almost 2 hours. I'm sure your brains are like, whoa, but I hope that you found that helpful. Were there any questions that you guys had? I asked at the beginning, but you may have come up with some questions that you have since the beginning of it.
On number 17, you got -3 because you put x plus 3 equals, or how did you, I'm sorry, I'm confused on the center part.
Okay, so it's coming from this. So we're doing the opposite of what's inside here. Yeah.
Okay, perfect.
So
I just wanted to
opposite of that.
confirm.
Yep, and then the opposite of that. Yep, that is correct. You got it. Anything else you guys thought of?
On one of those first problems, I had a question about, you used a bracket instead of a parenthesis.
Okay.
And I just was wondering why earlier, but I was still looking for the form. On number 4.
Okay.
But is that still because even though that is exactly where 0 is, it falls into that number?
Yep, because it has the equal to part to it.
Okay.
And that's
Okay.
always going to be the way it is. When we're finding the domain, you're always going to put whatever's inside greater than or equal to 0, because we need non-negative numbers, right? So that greater than 0 is the positive part. Equal to 0 is fine too, because I can take the square root of 0. Square root of 0 is just 0. So that's why we can have the equal to part. We just can't take the square root of any negative numbers. So we need non-negative. I say positive because sometimes people are like, why are you saying non-negative? It's hard to wrap my head around. But really, I mean, precisely, mathematically, they're non-negative numbers. But, if you think about this part, numbers that are greater than 0 are positive numbers. Okay? So... yeah, somebody asked if this video is going to be available. It usually takes, because I upload it to YouTube, and so for a 2-hour video, it could take up to an hour to get that processed and everything and up to YouTube. So I will definitely put it up first thing in the morning if it's not done before I go to bed tonight, but if it is done, then I'll get it posted tonight. Okay?
With the square power, so you had an example with all like real numbers with the infinities.
Like here.
So yeah, so is that just with the cubed root, or is that any number higher than 2?
Any odd root. That's a good question.
Okay.
So if it's like a 4th root or a 6th root or something like that, we'd still have to do this, greater than or equal to 0. But if these are odd roots,
You can just do the infinities.
yep, it can be anything.
Okay.
Okay?
Thank you.
Yeah, good question. Anything else you guys can think of? I appreciate you guys being here, and I hope that will be helpful for you. I said at the beginning of it, but I'm going to say it again. If, before you take the exam, I highly, highly, highly recommend you going through, go to that announcement that I gave you. I gave you a practice exam that you could kind of go through that might be really helpful for you. There's also the study guide that will give you more questions that you can kind of work through. So if you're like, oh, I'm really struggling with rationalizing denominators or something, then you can go pull a few, questions from there. Because remember, these specifically are the concepts that you will be tested on. So if you guys didn't take a picture of that already, I would probably take a picture of it and just make sure you know how to do those skills, or you have those formulas memorized before the exam. Okay. All right. Well, I guess we will leave it there. And has everybody figured out your calculator okay, and how to change like from radical form to a decimal? Tried to explain.
Is that just those double arrows that you explained?
Yep.
Okay.
So if you just click on that, it toggles, it goes back and forth, back and forth. Like I said, it will do that with fractions to decimals or decimals to fractions, but it also does it from square roots to decimals as well. So you can go back and forth like that. Okay. All right. Alrighty, well, I will pause this here then, and